Hi everyone, my name is Tyler Hawkins, and this is Software Engineering is a Loser's Game. I hope you're enjoying the conference so far and super excited to talk to you today and present on this topic. This talk is based on an article that I wrote about 2 years ago that got a good bit of traction in the engineering community, and I've been wanting to speak on it for some time, so I'm excited for the opportunity to do so today. As I said, my name is Tyler. I'm a senior software engineer at Webflow. You can find me on all the usual places online, LinkedIn, Twitter. I also do a fair amount of writing and blogging, so you can find my work on Medium or Dev as well. And all of this info and more is available on my website, tylerhawkins.info. So with that, let's dig in. So software engineering is a loser's game. That's the title of the talk, and it's intentionally a provocative title. Just to clarify a few things, I feel like I have to clarify this topic does not mean software engineering is for losers. It does not mean software engineers are losers. That is not at all what this concept or what this idea means. So with that out of the way, you are all winners, you all are great. Let's learn more about this concept. So your follow-up question, right? So what does it mean? What does it mean to say that software engineering is a loser's game? So in order to understand this idea a little better, we need to go back about 50 years. This concept of losers' games versus winners' games was explained and identified by a man named Simon Ramo. He was a scientist and statistician, and he wrote a book called Extraordinary Tennis for the Ordinary Player. And in this book, it's about tennis. He talks about losers' games and winners' games. And in the book, he explains that, or rather he observes that there is a big difference in the way that amateur tennis matches versus professional tennis matches are played and won. So just think for a minute about, kind of the difference in a tennis game that you see if you're watching something professionally on TV and watching how they play compared to maybe yourself or some friends playing tennis near your home. What's the difference between the two games? And one of his biggest observations is that in amateur tennis, he calls it a loser's game. And what he means by that is that points are lost by the loser more than they are won by the winner. And so rather than just thinking about, who won the point, he began looking at why did the person win the point? What happened to cause the point to be won? And so what he found is that in this loser's game, where points are lost by the loser, is that they're often due to these unforced errors that are committed by the loser. So maybe the person double faults on their serve, right? The winner didn't do anything to cause that to happen, but the loser committed an unforced error and double faulted on the serve. Or maybe they missed an easy shot. They were just returning the ball and they hit it out of bounds. Or they tried to go for a smaller portion of the playing field and missed, right, rather than going for a larger portion. Or maybe they just hit the ball into the net. And so again, these are all unforced errors, and so you can think of the point being lost by the loser rather than won by the winner. So that's a loser's game. And so when you're playing a loser's game, especially in tennis, a winning strategy can just be to just keep the ball in play, right? To not try to do any particularly tricky shot, but rather just to return the ball. I'm an avid ping pong player. I work fully remote right now, but back when I worked in an office, I loved to play ping pong. It's a staple of the tech world, and I would play ping pong just about every afternoon. And I would see this play out. If any of you, are in the office or play ping pong or tennis, you'll often see this, that if you are, playing with someone who's fairly new or not very experienced, if you just return the ball simply and just keep the ball in play, over time, eventually they'll commit an error, right? And they'll miss, they'll hit it into the net, they'll hit it off the table. but they'll lose the game by beating themselves, essentially. So again, the winning strategy is just keep the ball in play. In a winner's game, however, it's kind of the opposite strategy. Points are won by the winner more than they are lost by the loser. And so it's not so much these unforced errors anymore committed on behalf of the loser. It's now more due to skill that's demonstrated by the winner, right? And so the winner has a really well-placed shot that's just out of reach of his opponent, or they are stronger, or they put more spin on the ball, right? But it's due to their skill that they win these points rather than the errors of the loser that are losing those points. So that's the difference between a winner's game and a loser's game, especially in context of sports with something like tennis or ping pong. And so why this application is important is that it's interesting to think about, not just in the context of tennis or ping pong or sports in general, but in life. And so the application that was made is that when thinking about losers' games or winners' games, you can figure out in any type of situation what kind of game you're playing. Is this a winner's game or a loser's game? And then from there, you should adapt your strategy accordingly. So that's the premise. That's the idea of winners' games and losers' games. And so going back to the title of the talk, software engineering is a loser's game. What if we consider software engineering to be a loser's game? What might that look like? And how might that change our strategy in how we play this game? So again, if software engineering is a loser's game, then a winning strategy might be simply to minimize our mistakes. And it's important, I should note, that as we talk about this, it's important not to take the analogy too far. Obviously, the goal of software engineering is not simply to minimize mistakes, because if that were the case, then the best software engineer would be the one who does nothing, right? Because if they do nothing, you cannot make a mistake. But that's obviously not the case, right? The goal of software engineering is we're trying to ship some sort of product or feature or whatever that accomplishes some goal, right? We're trying to make money for the business, or trying to simplify something for our users, or make the world a better place. We have some sort of bigger goal that we're contributing to. So just a little disclaimer, that's not the ultimate goal, is to minimize mistakes. But it is an important strategy in software engineering, is to minimize our mistakes. And so as we think about that, as we think about the goal of minimizing our mistakes, of simply keeping the ball in play, and if software engineering is a loser's game, it's interesting to think about in what ways do we commit unforced errors? In what ways do we essentially beat ourselves and lose in this game? And on the flip side, how can we keep the ball in play rather than hitting it into the net? Right? So that's the premise here. And so I've been doing software engineering for about 10 years now. And something that I've come to see, and a piece of advice that I would give, is that you can actually become quite a good software engineer simply by learning from your mistakes, and learning not to make those same mistakes over and over again. As you move, especially as you're newer in the field, as you move from a junior developer to a mid-level to a senior, a lot of times this growth simply comes from learning from your mistakes and learning not to continually make those again. There's a saying you may have heard, it's okay to make a mistake. It's not okay to make the same mistake twice. Twice might be a little strict, maybe it's okay to make the same mistake 3 or 4 times. But the point of that, right, is that if you're making the same mistake repeatedly over and over, that means you're not learning from it, right? You're not learning why it's a mistake or how to overcome the mistake, and you're not growing because of it, right? And so it's important that we learn from our mistakes. And so as we begin to think about that, what are some of these common mistakes or unforced errors that we might commit in software engineering? I brainstormed a short list. This is obviously not an exhaustive list at all. But these are some common mistakes that I see either in myself or in other engineers as I've worked. And so this brief list, I think we've got maybe 6 or 7 or 8 on here. But so the first one, not understanding the problem before trying to code a solution. You ever done that before? You ever jumped into trying to solve something when you didn't quite understand the constraints of the problem or what you're actually trying to solve in the first place? Maybe you think you understand, a small symptom of it, but you don't actually understand the root cause or the root part of the problem that you're trying to solve. You'll see this oftentimes, especially in interviewing. Every software developer, I think most at least, dislikes live coding. But one of those things that the interviewer often looks for is, did you ask questions to clarify the problem, to clarify the assumptions or constraints before jumping right in and coding? And the reason that we look for that is because it's an important skill that you figure out that you're actually solving the right problem before just diving right in, only to realize that you've gone far down the wrong path and now have to backtrack. Second common mistake or unforced error that we might commit is not understanding the tools or programming language you use. I've seen this in the past with maybe a developer that's new to, maybe they're early on in their career and they're learning to write tests for the first time, which is great, which is a great skill to have. And so maybe they're working in JavaScript and they're using Jest, and they're really just fumbling along with not understanding how to make assertions or how to use matchers in Jest or something like that. And so they just fumble along with the code for a very long time, when maybe a better strategy would be perhaps to just take a break for a minute and go watch a video on Jest for an hour or two and learn about the basics and the fundamentals of it, rather than trying to muddle your way through without having that solid foundation in place. So perhaps it's a mistake or an unforced error to just kind of guess or flail about and see what works, rather than taking a step back to learn the tool or the framework or whatever that you're trying to use. Another common mistake would be not carefully reviewing your own code before asking for a code review. There are a lot of things as engineers that we can do to be good stewards of the code and to be helpful when we submit our pull request for others to review. Some really common mistakes, right? You might leave, just some JavaScript console logs in your code that you were using during debugging, and you forgot to get rid of them before you submitted the pull request, or you had commented out some code and you left some random commented out or dead code in the file before asking for a review, right? And so that can be, a simple mistake, because that's going to increase the time that it takes for your code to get merged, because it's going to go through one round of review. The person reviewing the code will hopefully catch those things and say, hey, can you fix these? And then you'll go back. And so you've now basically increased the cycle and the time that it will take for the code to be reviewed. In addition to that, right, if it's a repeated offense or something that happens over and over, you may lose trust with those other engineers around you who are reviewing your code if you start to maybe gain a reputation of not reviewing your code very carefully or being a little sloppy in your work. So a little planning beforehand and just a little self-review before asking for a review from others can go a long way and help make sure that that's not an unforced error that you're committing. Another one on a similar vein might be to not manually test your code before asking for a code review. Maybe the code itself looks fine, but as soon as you spin it up in the browser, something obviously crashes or has a very visible bug, right? The other person reviewing your code, if they've pulled down the code locally or if that's something you do in your process, will catch that and obviously wonder, well, why did this come through here? How did you not see that earlier? In which case you'll have to sheepishly admit that, well, I didn't run it locally and I didn't actually check. So again, make sure not to make that unforced error. Be more thorough in your own testing and your own code before asking for a code review. Another unforced error might be not writing unit tests. This will very much depend on company culture and engineering culture, but I'm very much a fan of testing. Using unit tests and tests in general is a great way to ensure that your code works and to gain more confidence. Whether or not you're a big TDD fan, I think is up to you. I see pros and cons to both, but having tests is super important. And then another one, not following agreed upon company standards. If there are well-documented processes in place or expectations as far as standards go, trying to submit code or work within that process without actually following those things, and then wondering why maybe it's taking longer to do your work or to get something approved. Seems to me like an unforced error, that if there are constraints that have been agreed upon by the company, we should work within those, right? That's a very short list. It's only 6 items here, but I'm sure you could think of a lot more. I'm sure you could think of ways that maybe that you've struggled now or in the past, or maybe that those around you have struggled now or in the past, of these common mistakes or unforced errors that they've committed. So with that being said, I do think that software engineering can be a winner's game. As we talk, going back to thinking about amateur versus professional tennis, as you move in skill level from these amateur competitions to professional competitions, the fundamentals don't go away, right? The professionals, they still make mistakes occasionally, but you don't see them double faulting as often. You don't see them missing easy shots. They've mastered those fundamentals. And so on a similar vein, I think we as software engineers, as we begin to master those fundamentals and begin to learn from our mistakes and to stop committing the same unforced errors over and over, we begin to master the game of software engineering. And that's when it can become a winner's game. With that, we can start to move faster as we write code faster and get things shipped and deployed and fix problems for our customer faster. We begin to solve harder problems. We move on to bigger and bigger things, things that are important to the business or the company as we solve these core problems for our customers. We can help others grow, right? We can help mentor other software engineers and developers in our company, and help them to learn and to grow and to progress in their careers. And finally, we begin to innovate. This is where the real magic happens, where we begin to create new solutions within software engineering that can really fundamentally change our business and ourselves and the world around us. So with that, I think we're wrapping up pretty close to the end of the talk. But I just invite you to spend some time pondering. Think about this idea of losers' games and winners' games. Think about, what mistakes do I frequently make? What can I learn from my mistakes? And how can I stop making those mistakes? I think as we can do that, we can learn to level up ourselves and really move from this loser's game to a winner's game in software engineering. And a final invitation, again, just learn to play the game. Software engineering is a loser's game. I think that's true for a majority of us. It's a loser's game. Learn to play it well. A simple strategy to simply progress in your career is to learn from mistakes, learn to stop making those, learn to be more consistent and reliable. And then finally, again, figure out how to turn it into a winner's game. Thank you. That's all that I have. Hope you enjoyed the talk. If you want to find me again, you can find me online in all the usual places, and especially my website, tylerhawkins.info. Again, thank you so much, and enjoy the rest of the conference.